So that's a pretty quick run through of the PV effect, the photovoltaic effect, but at least you've got an understanding, you've got a basic knowledge of how the solar cells work, what the driving force behind your solar panel is, right? So now let's look on the next subchapter and let's look at the materials that you could use or that are being used to produce these solar cells and therefore to produce the solar panels. So the first one is the thin film material. So it's a very thin layer that can be applied to many different kind of materials, and you might have come across the thin film solar cells and solar panels in the ones that are fully flexible, so you can roll them up in a very tight roll in a bundle. So I'm not talking about the ones that you can bend a little bit, but the ones that you can really roll up. Or you might have seen them in some of the old school calculators, the small calculators that have a very small solar panel, solar cell in one of the top corners. That's also normally the thin film solar material. Now, as we're looking at the different kind of material options that you have for your solar cells and for your solar panels, I think it would be important, it would be valuable to know what the kind of efficiencies are that you can expect for the different kind of materials. And for now, just remember that the efficiency value lies between 0 and 100%, and the higher the overall efficiency of the solar cell, the better, right? We're always trying to get a really as high as possible efficiency from the solar cells and solar panels. We'll dive later on in this topic, what efficiency actually are, how they're being calculated, and what it means for you. For now, just remember between 0 and 100, and the higher the better. So for the thin film material, the overall efficiency, the maximum overall efficiency that you can expect from a solar cell is at the moment 24%. So that's the first material that I want to discuss. The second one is the group of the crystalline materials. There's the monocrystalline, polycrystalline, etc. This is the material that at the moment is the most frequently used type of material to build solar panels. And the maximum efficiency that you can expect within the group of crystalline materials is 28%. So this 4% extra efficiency of the solar cell is something which is normally a huge advantage, right? So most of the times, for the majority of the solar panels, we're using the crystalline material because, there's several reasons. It's more affordable, you're getting the higher yield, it's easier to produce, etc. But the thin film, you would use it, for example, because it's ultra flexible. You need to have it this flexible. If you're going backpacking and you want to roll up your solar panel and put it in your backpack, so then you would use the thin film material. Now, the next material is gallium arsenide. And gallium arsenide can give incredible performance yields. It is an incredible overall efficiency boost compared to the thin film and the crystalline materials, because you can get up to 36% in overall efficiency from gallium arsenide. So the reason why you probably won't be using gallium arsenide is because at the moment it's still incredibly expensive. So if you would have an absolute limited amount of space and you don't care about how much you're paying for your solar cells and solar panels, then you might want to consider gallium arsenide, for example, for special solar race projects, or for really specific conditions where you say, I want to have the maximum amount of yield. For a very small amount of service, you might want to go for gallium arsenide. My bet is, and that in your situation, and this is almost always true, it is way more profitable to just install a few more panels from the crystalline material as compared to spending 100 times more on your solar panels and going for the gallium arsenide. Now, the next one and the last one I want to mention are the multi-junction type of solar cells and solar modules. So here it's the same story as with the gallium arsenide. You can get even a higher yield. You can get up to 45%, which is really amazing. At the moment, this is the highest yield you can get from any photovoltaic cell. But they're more expensive again than the gallium arsenide. So only situations where money actually has no importance in the general decision process for what kind of PV cells you're going for, people would want to choose for the multi-junction. So for example, on satellites normally have multi-junction solar cells installed. Now, I thought it was just interesting for you to know which kind of materials are out there in the market, but it is most likely that you will go for either way the thin film or for the crystalline materials. And based on the assumption that you are grid-tied stationary, I think you will go for either way the mono or the polycrystalline materials. So the second two, I just want to mention them, but it's very, very unlikely that you'll ever go for them.